Web and file exploits. Well, this nugget's going to be short and sweet. We have web and file exploits. Now, there's hundreds of different web exploits, especially against Microsoft's IIS. And although it's improved greatly in recent years, there's still a lot of exploits out there. So we'll take a look at some of those exploits, especially two or three key exploits that we'll look at. And they're not really the fault of Microsoft or anybody, because you can have flaws in the kinds of things I'll show you in an Apache server or a Microsoft server, any kind of server. It's really more of a design flaw in the way a web page is written. We'll also take a look at file exploits, and this is where we can, pretty much the main idea here is we want to embed or hide secret data inside of files, and then I'll show you how to open that information back up out of image files using something called steganography. Let's get started with some web exploits here. Now, first of all, there's way too many web exploits to really identify. There's got to be hundreds of them out there against not only Microsoft's IIS, but also other versions of Apache server and many other ones there. Now, Microsoft's IIS does seem to have the most exploits that people are aware of. It seems to be a higher profile target. They have a broad distribution of web servers out there in the world. But in Microsoft's defense, I'll have to say that especially compared to IIS 4, the recent versions of IIS are much, much stronger than they used to be. It used to be we'd get dozens of exploits, pretty much every month years ago. And now we very rarely get too many exploits like that these days, although they're still there. Now, what I'll talk to you about here are not vendor specific. These are some key exploits that we'll discuss that could apply to any kind of web server, whether it's IIS, Apache, whatever it is that you use. It has to do with the way the forms or the fields are designed, or where the web page is designed. And this is where we have a human factor, because no matter how good your web server is and how secure it is, whether it's IIS or Apache or whatever, if someone has designed a web page poorly, it's going to circumvent that security potentially. So we'll take a look, first of all, at hidden form fields here, as well as escape paths and parsing errors. And I'll just show you those practically by demonstration and explain them as I go. Now, the first thing I want to recommend is that you also do each one of these exercises I'm about to show you. There's a couple of other things you need in order to perform these exercises, however. You can need to get something called WebGoat. You can get this actually from a number of different places. I got mine from SourceForge.net, which is the primary distribution avenue for this product. WebGoat is really a tutorial. It's designed to show you the various kinds of weaknesses that can be put into a web page, and so you can help train yourself if you're a web designer or you manage web pages, that can kind of help train you to do more secure design of your web. The other thing we'll use is something called Peros, and I've got 3.2.9. Again, you can get this from, I don't know, a number of different sources. And there's a number of different versions out there, but this is the most recent one as of this writing. This recording, I should say. In any case, what Peros does is it intercepts traffic to and from a web server. And you have to configure this as a proxy for your system in order to do things such as perform the exercises with our WebGoat product. And WebGoat will also install an Apache server for you. So you don't have to go out and buy expensive server hardware. All this can be run on a pretty generic Windows XP computer. Before we get started, let me show you a change that I've had to make in Internet Explorer here in order to be able to use the Peros application. And by the way, Peros is not running right now, so that's why there's no page displayed right now, because I'm going to use it as my proxy. To configure Peros as your proxy, go to Connections, LAN Settings, and after you've installed Peros, just go ahead and check this box and enter in the settings like you see them right here. By default, proxy usually is on 8080 as your port. You can change that if you want to, but there's really not a compelling reason to so far. Okay, so once we've got that done, the next thing we'll need to do is go ahead and start our Tomcat server. Now, in order to do that, that's just an iteration of Apache. In order to do that, I'm going to go to webgoat.bat file here. This is a file that's included with WebGoat, and it works hand in hand with Tomcat. So if I double-click to launch that, then it's going to go ahead and start the engine for me, start the web engine. Now, don't be alarmed as you look at this and say, okay, I'm waiting, I'm tapping my fingers on the desk, I'm going to go get a cup of coffee, I'm coming back, it doesn't look like it's doing anything, well, I'll let it sit overnight, maybe something will happen. This is as far as it gets. It's doing exactly what it's supposed to do right now. It doesn't bring up some kind of pretty graphical user interface or anything like that. It's just a service that's running on this computer right now. So when you get to this line here, server startup in so many milliseconds, you're done. Don't close this by clicking on the X. If you do need to stop it, you can click the X or Control C, but just minimize it. That's our service, and we need that in order to be able to run our web server. The next thing I need to do is to get Paros starting. Now, I'll point this out. When you install Paros, it's got a next finished installation, and it's supposed to associate this shortcut with the application, but it's broken. For some reason, it just doesn't work, and then you get that little, as soon as you double-click it, you get that little flashing search light that goes back and forth the screen saying it's going to browse or cancel so that you can set up the link yourself. Just let it browse, it'll find it, and it'll find the appropriate link that it needs. And then you'll be able to double-click on it and get it going. Okay, the next thing we'll need to do here then is to click on Filters and Enable All. So if I'll go to Tools, Filters, and then I'm going to just enable all of these items. Now, for some reason, our Enable All button doesn't work. Again, sometimes this kind of software, not all the buttons and things work, and sometimes these things even just crash, but that's just how it is sometimes. And the next thing I'll do to configure this application is just go to Trap. This is where we're going to be working. We're going to be working from within this window. Now what we want to do is we want to trap our requests and our responses or leave those clear. If I leave these clear, from this point I can pretty much just browse the internet as normal. So I'll just click on this Internet Explorer item. It's connecting to cbtnuggets.com, which is what I set up for my home page. And down here, I see that it gives me a prompt, and that's why I was kind of seeing nothing going on there. It says, do I want to accept a cookie? Okay, I'll just let that happen. So just letting that happen here. And now we got the web page. So for the most part now, I can just browse pretty much as usual. What I could also do, however, is to trap the request and the response. And if I'm able to do that, then as traffic goes back and forth to that web server, I can modify it in transit. You see, there's kind of a tacit understanding with web programmers. They'll say, I created this HTML web page, maybe it's got a little applet in it or something like that. I'll send it to your computer, and then you fill out a form and send it back to me. All you should be able to send back is the stuff that you typed in, and only the stuff that you typed in those fields. And I can restrict what kind of data goes in there and all that sort of stuff. Well, what we can do is we can say, no, I'm going to put in the data that I want to go in there, and we'll trap the request, edit it before the response goes back, and then click on Continue. Next, I need to go to the WebGoat page here that I've got on my local system. So I'll just HTTP, localhost, WebGoat, and attack, and then it gives us a prompt for username and password. Now, this is going to be real hard, guessed in both fields here. That's just the default for WebGoat. Okay, it's not designed to be secure, it's just designed to teach us lessons, so I guess we'll learn lessons about using bad passwords. So we'll enter that information in. Over here in Paros, it says, hey, do you want to accept this cookie? Okay, I'll go ahead and accept that cookie, and then we should see that we get our WebGoat web page right here. All right, now that's pretty much all there is to the beginning of this. We're now ready to start some lessons. Let's take a look first of all at how we can possibly, now I would never do this, how we can possibly do e-shoplifting. And for this, I'll return to my WebGoat page over here, and then I'm just going to go over here to this hidden field tampering. This is just the lessons that we can do, and we'll go through each one of these if you want to, and you can do those on your own, and just click on one and see what kind of things it will tell you about. In this case, it's simulating going to a web page to buy a really nice 46-inch HD TV. Wow, that looks pretty cool, but it's $5,000. Great Scott, I can't afford $5,000. So what I'll do is I'll just trap any responses that I get out of here, and I'm going to go ahead and start entering in some ideas here. So let's say I've got me, I need a TV, my brother-in-law. I'm going to get one for my brother-in-law too, and we're going to go ahead and update the cart, or just click on purchase. I guess we'll just do that. So I'll click on purchase here, and then I get Paros up here that says price equals $4,999 each. Wow, great Scott. Well, how about something more reasonable? I mean, aren't those kind of overpriced anyway? How about $49.99? Then we'll click on continue, and we're sending the data back now in the way that we have modified it. And guess what? I just bought 2 HD TVs for only $99.98. Now, of course, this has obvious ethical problems, but if you take a look at this in a number of different ways, this is something that could potentially be easy to get away with. Who's to say that you're the one that changed the price? All that happened was data got sent back to their web server through a lot of different hops, a lot of different servers along the way, hackers all over the internet. Anybody could have changed that. The other thing is, if this is a pretty busy website, it's very unlikely that a human is actually going to look at that number. So it could just go straight through the system without anybody ever knowing, and I could get 2 televisions here for only $99.98. By the way, there was was I just learned of this. There's someone that went to a website out there that's a well-known website for buying, plasma televisions and things like that. And they actually did this clear up to the point where it said purchase. And then they got a little bit nervous and saying, boy, if they're tracking this or something like that, maybe they'll send the law after me or something like that. And since it's across state lines and on the internet and everything, it's probably a federal crime too. So you got to be careful of that. In similar fashion, I had another hacker that I know of that I talked to a while back, and he was doing a pen test for a large corporation that had an online ordering thing. And this corporation apparently did like large construction machinery, and they sold, humongous cranes and all that kind of stuff. Well, he decided to just test this out, and he manipulated some fields and got into a SQL database he wasn't supposed to be able to access, and he ordered a crane, not the whole crane, but just the bucket that goes on the front, but it weighed many tons. I mean, it's for a huge crane, and he ordered that bucket to be shipped to the CEO's house. Well, he meant to delete it. He was just going to take a screenshot of it and show that he could do it, but he got distracted and forgot all about it. About a week later, this gigantic bucket from a crane shows up on the front yard of this CEO, and he wasn't very happy about that. So anyway, this kind of manipulation can let you have all kinds of fun or all kinds of trouble, however you want to think about it. All right, now this one can be a little bit more of a shot in the dark, and we've moved on here to path-based access control. With this one, I want to try to find content on the web server, and I want to go to directories that they would not normally allow me to access. And with this is what we can do if we want to use something called escape paths or escaping paths. So we'll go here, and I'll take a look at these files. It's going to allow me to look at these files. It says I can look at the files in temp, tomcat, web apps, webgoat, images. Okay, great. However, in this case, I'm going to cheat a little bit just so that we can see what other kind of files are located there. I'm going to go into that directory, Tomcat, web apps, webgoat, and images. Here's all the images that we see right here. Okay. So what if I wanted to do something else, though? What if I wanted to find something else that was in a different location here? What if I wanted to instead get, let's just go up a step here. Whatever the license is. Yeah, what if I wanted to get this file instead? Well, how can I do that? Well, see, I'm not directly allowed into that directory. I mean, if you take a look at where I'm allowed in this directory in images, but I'm not allowed in any of the other ones. So in order to circumvent that, I can just type in something like ... // and then license. Remember, that was the name of the file that I wanted to see there. So I'll just click on go. Now the key here is all of this stuff on the front of this / information. This is what we call our escape attack, and it's going to allow me to access additional files that they wouldn't otherwise allow me to see. Now, one thing I might do if I'm looking for things, of course, we already know the name of the file, but normally you might not. You might look for common web files that appear on web servers that administrators use, but that you're not supposed to look at. Maybe you would want to try to find a log file of some type for a specific web application and see what kind of logs are recorded there. Maybe you'd want to see a file that might contain passwords commonly or something like this. So we'll click on go, and congratulations, access to that file has been allowed. Wouldn't have normally been allowed, but because of these pre-appended characters, I'm able to do so. Now finally, let's go ahead and take a look at another one here. Now, this is going to be parsing errors. We're going to go to something down here called fail open authentication. Now typically you get a dialog box like this. You have to know the username and the password to be able to get wherever it is that you want to go, right? Well, in this case, we're going to again use our Peros application to intercept it, intercept the traffic. And I'm going to go ahead and minimize that for now. And then we're going to be able to manipulate this sum to trick the web server into allowing us access even if we don't know the password. Now, you do have to know a username of some kind. One thing that you could do is type in admin. That's a very common username. And guess what? They already also have administrator access. So if we could get in as the admin, you could really go far. You can try just about anything you want to use here. Very commonly used names are, first initial plus last name, that kind of thing. In my case, I'm just going to type in, anything. I guess I'll type in admin. And then I'm going to enter in a password. And this doesn't really matter what I type in. I'll just type in, whatever that is. And then I'll click on login. Okay, and I can say yes if I want, but I'll say no for now. Now, Peros is blinking at me and it wants me to know if I want to continue on with this. Well, what I'll do here is I'm going to change this form. This is what it's about to go back to the web server. This is my response part that's been trapped. I'm going to hold this up. And by the way, sometimes you have to do this fast because the web page might time out. And I normally do this faster, but I'm talking at the same time. But anyway, I'm going to delete where it says password equals. So I'm just going to stop right there, hit delete, and then click on continue, and I'll just let the keep clicking on continue till it lets me go through. Then let's go ahead and take a look at what it allowed me to do. Congratulations! You've successfully completed this lesson because I have now been welcomed to this web page. And the reason why this worked is because some applications, web applications, don't handle errors properly. Just by deleting the password section there and deleting the password form part, it didn't know how to handle it, and it allowed me to come through onto the web page anyway. Now, the next thing I want to cover with you is just a bunch of different little hacks that don't really deserve a topic of their own other than miscellaneous, quote unquote, but they're very interesting nonetheless and can really be exploited to great advantage. Some of them aren't really application exploits, so much as they are ways of hackers being able to conceal things inside of other components in the operating system. And the first thing I'm going to show you there is something that relates to the NTFS file system. And this is something called alternate data streams, or ADS. So for example, here I'm in a files directory, and if I do a dir, I don't see any files there yet. It's a brand new directory, I just created it. So I'm going to type in Notepad, and I want to create a new file, so I'll just call this test.txt. Okay, and it asks me if I want to create the file because it couldn't find it there already. I say yes, and I'm just going to type in some text. All right, this is text. Big deal. Okay, great. So now I'm going to go ahead and exit this file and save it. And as you would expect when I do a dir, well, there's my file right there, and it's about 14 bytes in size. All right, let's try that again. This time I'm going to do something a little bit different, though. I'm going to use the alternate data streams. Now I'm going to type Notepad again, and I'm going to type test.txt. Then I'm going to do a colon right after that, and I'm going to type in hideme.txt and press enter. It says it can't find the file. Do you want to create a new file? Yes, and I'll say, some other text. And what I've typed up there is exactly what I can do with this. This is just secret text that I can bury inside of another file. Let me show you how that works. I'm going to go ahead and exit and save this also. Now, when I do a dir again here, watch what happens. Well, I don't see that other file that I typed. I don't see a hideme.txt. And my file size, well, it hasn't grown either. Guess what? Inside of test.txt is another file called hideme.txt. And this is what hackers can use to put secret information in, to put their own password reminders in a file or something like that, because they want to be able to get back into a system or be able to open up a file. Another thing that could be done with this, and not a lot of hackers have really exploited this quite yet, but it's certainly possible. Another thing that could be done is to bury one application inside of another. For example, maybe you want to go ahead and work with calc.exe, and you know what calc is. That's your calculator that you get, this guy right here. Well, I could work with calc.exe, and I could wrap inside of that trojan.exe, so that the next time someone launches calculator, it actually launches Trojan. Well, the next question would be there, well, if I don't see that file that I just typed in there, that hideme.txt, and the text that I typed inside of hideme.txt, how do I access it? Well, you have to have something that's written to the NTFS file system, and it's an application that has to be able to extract from it. For example, PacketStorm has a utility called make, strm.exe, M-A-K-E-S-T-R-M.exe. Mark Rusanovich from sysinternals or WinInternals, that's really both the same site. He's released an item here as well that displays NTFS files and their content. Haysoft has also released something called List Alternate Data Streams, another product that shows the contents of those files. So certainly there are ways of doing it, but you can't just do that from the command line like I've shown you how to create it. Once you've created it, you have to use another method to be able to look at that data. Now, there's another thing called field codes, which is kind of similar to what we're seeing here with this alternate data streams. This is something that relates specifically to Microsoft Word. If you get an email and it's just a Microsoft Word document, someone could embed inside of that Word document a certain kind of a hidden field code, and when you open that document and save it, even if you didn't make any changes to it, it has ways of being able to look at your hard drive and send files from your computer outside of your computer, even outside of a firewall, to a destination. And that's because of this hidden field codes item. If you want some countermeasure against that, you can use the hidden field detector. That's available at woodieswatch.com. Woodieswatch.com. That's a really good Windows website. You get a lot of good information about the Windows operating system there. And then another thing relating to files is something called steganography. 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 It's kind of a weird word, but really what this is, it's the process of hiding secret data inside of images, like a JPEG or a bitmap or a PNG file or something like that. It's a very popular method of hiding data inside of files that nobody would ever be able to think to look for. When you hide the data in the files, it doesn't change the size of it at all. In this case, for example, I'm using a tool called Image Hide. This is one of the tools that we can use for steganography purposes. And I think I got a file here from a trip to Hawaii that I went on. Let's see if I got it in here somewhere. In any case, I'll try to find it. I reduced it in size because otherwise it's too hard. It's too big to see here. But there we go. Okay, there's one I reduced in size. Some nice flowers that I found somewhere there in Hawaii. But what if I've actually got secret data in here? So in any case, maybe I've typed in text like this to my friend, my black hat hacker, and we're going to try to share administrator passwords to a bank here. And of course, Gotham City Bank is a comic book bank, so that wouldn't be real. And then this is the password to that administrator account on that website. Have fun. Now, how would I actually go ahead and work with this data and deliver this to my friend? Well, what I can do is to take this text, embed it into the graphics of this file, and it will not even change the size of the file, and it's indecipherable or indistinguishable to anybody else. You would have to know that there was secret code in there in order to get it. And even then, you have to know a secret password. So what I would have to do here, if I want to obfuscate this, and that's obviously what I would want to do, is I want to encrypt this information. So I'll encrypt and click the encrypt button right here, and then I'll enter in a password, okay? Pass secret, something like that, okay? I know, I'll just use hacker's rule, because I've used that in the past. Hacker's rule. Okay, and so we'll use that one, and now notice that it sends it through a hash and encrypts it, and now it's obfuscated and not easy to read anymore. So I'll close this, then I want to write this data to the disk, and then I'm going to go ahead and save this file. And I'm going to save it as, you have to save it as a bitmap or a PNG file. You can open it multiple formats, has to be saved as a bitmap, however. So then once I've done that, I'm going to go ahead and just save it. Let me get rid of the extension there for bitmap, and save, and there we go. Now what happens here is I'll close this, and let me go to where I saved the file. I saved it into my I think I saved it in my files. It's in here somewhere. And I'll go ahead and, there it is. It's just not in order. And there's the file with the steganography in it, with that secret message in it. So I email this to my friend. My friend opens it. In the past, we've discussed what our secret password is, our shared password that we have together. He opens it up and he says, oh, isn't that a nice picture of flowers? Somebody that's shoulder surfing or a passerby in his cubicle says, oh, isn't that a nice picture of flowers? Nobody would have any clue that it's actually got potentially damaging or secret information inside of it until he opens up Image Hide on his end, clicks Load Image, clicks to open up that bitmap that I had saved earlier, and then he wants to read the data. Oh no, it's all obfuscated and encrypted. Nope, not a big deal there. Just click on Decrypt. Hackers_rule is our secret password, and now he's got all the information that he wants out of it. Okay, so a really slick utility for concealing information and making it difficult to find to anybody that wouldn't otherwise know that it's there. In this nugget, we took a look at web and file exploits, and we started off with a discussion of web exploits that we saw could happen on any kind of a web server. I mean, we exploited them on an Apache server, but if a web programmer had written them in the same way and stored them on a Microsoft server, the same vulnerability would exist. So it's really platform independent in that respect. Also, we took a look at some file exploits, and primarily what we saw there is that there are ways of hiding data and stuffing it into secret places where you can, maybe keep a secret password someplace or something like that. And what we looked at last was our steganography demonstration, where you can hide whatever kind of text you want in an image file and make it impossible for somebody else to even know that there's something in there. And then, of course, if you know the shared password, then you can open the file and decrypt its contents. I hope this has been informative for you, and I'd like to thank you for viewing.